You're deciding if the relation defines a function. Remember that all relationships are either functions or not functions. So in 1a, we first need to review what domain and range are. So domain is the x value and my range is my y value. Remember that an x can only go to one place. So you as an individual can only go to Target or Walmart. You can't go to two places at the same time. So your x's cannot go to two y's at the same time. Okay, so in the first one, our domain is -3, 3, 4, 7, and 10. If the number is listed more than once, in your set of points, then you only have to list it once in the domain. And you'll see this in the range. So your range is -2, 6, -7, -1. And I just went in order that they're listed. You can arrange them from least to greatest, but that's not necessary. See how 6 is here twice? So we only need to list 6 once in the range. So in this case, this is a function. 1b, we have our domain is -5 to -3. And then our range is going to be 1, 2, 3, and 6. So if you notice right here, this is not a function. The reason why it's not a function is because our 2 goes to 1 and our 2 also goes to 3. So because of these order pairs, our set is not a function. So our x's are on the left and our range is on the right. Remember, we cannot have an x that goes to two places at the same time, so therefore this is not a function. But our domain is going to be 4, 7, and 12, and then our range is going to be 5, 13, and 8. Again, this is decide whether the relation defines a function. You're looking for the vertical line test. So what we are trying to determine is if any point does this relationship cross our vertical line more than once. So let's see what this looks like. It's passing the vertical line here. So far it's doing so good. It is a function right now, but look right here. So automatically, because I have several points on the vertical line or more than one, this is not a function. And it's the vertical line test. The domain and range of the relation is relational function. You're going to determine if the relation is a function based on the pass of the vertical line test. That means it's a function. A fail means it's just a relation. So when you're looking at domain, you're looking at x's and y's. Our domain right here is at 1. So this is at x equals 1. And it opens to infinity. And then our range, there's nothing stopping it from -infinity. And then we're going upward to infinity. So our domain is included 1 to infinity. And our range is -infinity to infinity. And this is a fail, the vertical line test. So therefore it's not a function. The reason why it's a fail is because we have a line, a vertical line, and our function crosses that vertical line more than once. It's going to be domain and range. These are both included. So we're going to talk about -3 to 0. So this is going to be -3, 0. They're both included. That's going to be our domain. And then our range is going to start from the lowest point to the highest point. That's going to be -5, and that's included, all the way to -1, which is also included. And then this is a relation because it passes the vertical line test. I'm sorry, the relation is a function. Number 7 is asking us to find the domain and range of the relation. The relation is y equals s squared plus 8. The domain is going to be -infinity to infinity, and the range is going to be 8 to 0. The reason why it's 8 to 0 is because we look at this number line over here on the right for the graph. Our minimum for the y-axis or our y-intercept is going to be 8. So we just continue to open upwards. So it's included through 8 and it goes to infinity. Square root function, you're going to take the base of the square root function, and that's going to be the x plus 2, and make it greater than or equal to 0, because you don't want an imaginary number underneath the root. So you're going to 2 plus x is greater than or equal to 0. So this is all for the domain. You're solving for x, subtract 2 from both sides. So you get x is greater than or equal to -2. That's included because it's a greater than or equal to. So it's going to be -2 comma infinity for the domain. And then if we look at our graph right here, it says -2, 0, right there. So the y value of the starting point or the vertex of the square root function is going to be the first value of the range because it starts at 0 and it increases to infinity. So our range is going to be 0 to infinity. Again, the 0 is included because that's the vertex of the... Number 11, we're looking for domain and range again. You want to concentrate on the denominator for the domain and the behavior of the graph for the range. And it's basically something we can observe. So the graph on the right is the rational expression or rational function. To determine the denominator, you're going to set the x minus 6 cannot equal 0 because that's going to be where we have a union. And then we're also going to have a union for the range. So we're going to have a union for the domain and range. Let's look for the domain first. So we're going to say x minus 6 cannot equal 0. And then we're going to solve for x. So add x to both sides. X cannot equal 6. So that's where we're going to have our union. And we can illustrate this with a vertical asymptote where x equals 6. Right? Because our graph just approaches that. It doesn't ever touch that vertical asymptote. And then you have your range. So your range is kind of already apparent because the degree of the numerator is less than the degree of the denominator. Automatically your horizontal asymptote is going to be y equals 0. And that's kind of what we observe here. So if you look at this horizontal line at y equals 0, our graph does not ever touch that horizontal line, just gets very close. Again, this is a horizontal asymptote. So that means that our range is going to be -infinity to 0, union 0 to infinity. F of x equals x squared minus 2x minus 7, fine. So you're basically, these are all x's. So this is x equals, right? Whatever is inside those parentheses. This one is a y. So this is a y equals. So the way that this goes, you're going to substitute this this value of x, wherever you see an x, into this function. Let's see what that looks like. So we're saying that x equals -1. So when you substitute it in, your solution is going to be -4 for A. B, x is 0. When you substitute that in, your solution is going to be -7. And number 4, x is 4. Substitute that in, your solution is going to be 1. And then for D, it's different. So you're going to need more space to see this. So it says x such that f of x equals -4. So you're saying that y equals -4. So the whole equation is going to be equal to -4. You're going to add 4 to both sides. And then you're going to have x squared minus 2x minus 3 equals 0. Then you're going to factor. Our factors are going to be x minus 3 times x plus 1. And then you solve for x. So our first 0 is going to be x minus 3 equals 0. So x equals 3. And the second one's going to be x plus 1 equals 0. So it's x minus 1. So our solutions for that are going to be -3. All your solutions together. Where x is -2. So we're just going to go to -2. And we go up and I have 2. And then we're find f of 5. So that means x is 5. So x is 5 here. Go up. I'm going to get 2 again. Find x such that f of x equals 6. That's going to be a y. So this is y equals 6. So I'm going to go to 6 and then I get -6. So my x is -6. And then it says to find my domain. My domain, we're going to start from left. So I have -6 to 6. And then my range is going to be 0 to 6. Sorry, net. Intervals of increasing and decreasing. We only are concerned with what's happening on the x-axis, and everything's going to be in soft parentheses. So we're just looking for intervals of increasing and decreasing. So the way that this goes, it's decreasing when your money goes down, It's constant when it's flat, and it's increasing when it goes from small to larger up the hill. Down the hill decreasing, constant when it's flat, up the hill is increasing. So increasing from 3 to infinity, decreasing from infinity to -3, and then constant from -3 to 3. And number 19, we have decreasing, and then we have increasing. So it's increasing from -1 to 0. -1 to infinity, and then decreasing from -infinity to -1.